Hello everyone. In this video we will discuss about control valve characteristics. As we know that for the better performance of the control valve we must design plug with a special characteristics. So the control valve's performance is totally depend on its different characteristics. For example, if we want quick opening, then we have to follow a different characteristics, and if we want to make a linear flow control, then we need to choose the different characteristics. Based on the valve's characteristics, the control valve's trim, basically the plug part, will be having a special design. So first we need to know what is the control valve characteristics. So the definition of flow characteristics is relationship between open flow area through a valve trim and valve stroke between 0 to 100% for linear actions valve, just like globe valve, and 0 to 90% degree for rotatory valves. There are two types of characteristics. One is called inherent valve characteristics, a second is called installed valve characteristics. Here we are going to learn about inherent valve characteristics, but installed valve characteristics can be little bit different from the inherent valve characteristics, because installed control valves have different kinds of process parameter due to its upstream pump design. So an inherent flow characteristics is a relation between valve opening and flow under constant pressure conditions. The inherent characteristics of a valve is obtained when there is constant pressure drop across the valve, but that is not possible in valve which is installed in the pipeline, because due to the pump head pressure, due to the line different losses, and due to the control valve losses, there could not be a constant pressure through the valve. So that is why we call installed characteristics is different from inherent characteristics. But to achieve maximum to install characteristics, we need to learn how inherent characteristics can be defined. So the process fluid is not flashing, cavitating, or approaching sonic velocity. The actuator is linear. Some valves have inherent characteristics that cannot be changed, such as full port ball valve or butterfly valve, but other valve types such as globe type, the inherent characteristics can be changed to suit the applications. And the inherent flow characteristics do not reflect the actual performance of the valve installed. The ideal condition of the constant valve pressure drop is unlikely to be true. The operating characteristics will having the deviations from the inherent characteristics is called the installed flow characteristic, just because of not constant pressure through the valves. If we talk about the types of the valve characteristics, then there is three types of valve characteristics: quick opening, linear, and equal percentage. So the curves between the percentage flow and the percentage valve opening is look like this. So this line is so linear, like it's a linear characteristics of valve. This is for quick opening characteristics, and this is the equal percentage opening. Now we will learn how these types of characteristics can be selected for which types of valve and how it's impact the performance of the control valve. So the fast or quick opening, as we know that this is the fast and quick opening. There are many types of application in process industry where we require fast or quick opening. So first let's see how the fast opening characteristics works. So see this graph, flow versus valve stroke, or you can say the valve opening. If we have opened the valve very small, then if we track this line of quick or fast opening, for a small opening of valve the maximum flow we can get like this. So that means if we open small portion of valve, then we can get very high flow. So that is called fast or quick opening. So here we can understand by this methods like maximum flow area at minimum travel is 25% stroke, that is equal to 75% of flow. Used in on-off valve application, example flare vent, safety, cooling water system. The maximum CV must be obtained quickly. High flow for small valve opening, that is what we are discussing here for quick and fast openings. Now a quick opening valve plug produce a large increase of flow for a small initial change in stem travel. Near maximum flow is reached at a relatively low percentage of maximum stem lift. The quick opening plug are normally utilized in two position, on and off application, but they must be used in some linear valve applications. This is possible because its initial linear characteristics at low percentage of stem travel. The slope of this linear regions varies a step which produce the higher initial gain than the linear plug, but so increase the potential stability of the control valve. So the application of the quick opening is used for on-off services and equal used for process where initially large flow is needed, just like as I told you, like for flare, vent and safety and cooling water services we prefer the quick opening. And that means whenever you will select the quick opening, then there will be special types of design of plug where if the valve travels very less, then its flow will be go higher position. Now the linear characteristics. If you see this red line going from here to here, this is the linear characteristics of valve. It's the same. The percentage of opening is equal to percentage of valve flow. Just like if the valve is open 25%, then the flow will reach to the 25%. If we have opened the valve at 50%, then flow will go to the 50%. That means the opening and the flow rate are in linear, so that characteristics is called linear characteristics. The applications of the linear characteristics is used in liquid or flow loop, and also used in applications where pressure drop across the valve is expected to the remain fairly constant. It is used when pressure drop across the valve is large portion of total portion pressure drop. So these kinds of applications if we have, then we can choose the linear characteristics. Now the equal percentage characteristics. So this graph is showing equal percentage of characteristics. So how this work? So let's understand with these examples. So basically equal percentage change in stroke produce equal percentage change of existing flow. So valve goes from 50% to 60%. The change of the opening or stroke is 10%. Now at 50% this is the flow, at 60% this is the flow, and change in flow is 840 and the percentage GPM is 70%. The valve goes to 60 to 70%. Now we have changed again 10% opening, and flow at 60% is 2040 and the flow at 70% is 3470 GPM. Now there is a valve 70% and here is the flow is also again 70%. So that means if we have changed the equal percentage of stroke time, then change in flow will also be equal percentage. That means if we have changed the 10% of the valve opening, but still from 50 to 60 the change in flow is same from in 60 to 70%. So this is the valve characteristics equal percentage. So the equal percentage valve plug produce the same percentage change in flow per fixed increment of valve stroke at any location on its characteristics curve. So this is the example what we have seen here, and the application of equal percentage is used in processes where large change in pressure drop are expected, and used in processes where small percentage of total pressure drop is permitted by the valve, and it's used in temperature and pressure control loops. The characteristics selections guide is here. like if you have different scenario while selecting the valve characteristics, then we can see like this is the tables where the applications like level control, temperature control, chemical additions, process control, pressure control, flow control, and slurry applications. The preferred characteristics is linear, equal percentage, like this it is defined here. For the globe valve, yes, linear is okay for level control, and that for the temperature control it is okay. So for the globe valve, this preferred characteristics with respect to application is given here, and for other types of valves also given here. So these kinds of uh, tables can help you while selecting the valve characteristics. Now the thumb rule of selection of valve characteristics are the characteristics used in process if most of the pressure drop is taken through the valve and the upstream pressure is constant. A linear characteristics will be provide better control. If the piping and the downstream equipment cause the significant resistance to the system, equal percentage characteristics will be provide better control. For the batch processes, on-off control, pressure relief, drains, fast and quick opening, just like flare services, this on-off fast and quick opening will be better options. For fast reaction, quick change flow control, pumps recirculation, constant pressure drop, linear characteristics will be best options. And for very precise change in flow in small increment, good of chemical pH control, temperature control, low pressure pressure drop, in these applications equal percentage is the best options. So if you see the characteristics for different kinds of valve, then this is the curve between the opening and the flow. So this is the fast opening, this is for linear globe, and this is for ball valve, and this is for butterfly valve, and this is equal percentage globe characteristics. So these are the characteristics lines for globe valve and rotary valves. Based on the characteristics, we have the design of plug. So this is the plug guided and this is the cage guided. For the plug guided, if we talk about the quick opening, then our plug will be like this. For linear operations, we have these types of plug design, and for equal percentage we have these types of design. But if we use the cage guided trim, then we can see this is for the quick opening, this is for the linear application, and this is for the equal percentage. So this empty space you can see, and this define the valve characteristics, and based on this different types of trim, the valve can be operated with different kinds of scenario. So this is all about control valve characteristics. So with the help of these characteristics, we will do the sizing, and we will see what are the consequences of different types of characteristics if you are not following properly, because we know that if we will not use the proper characteristics, then there will be a lot of problem with the valve functioning, just like sometimes noise will be open, sometimes flashing, choke flow will be there. So these kinds of consequences will be there. So in next videos we will understand what happen if we will have a wrong selection of the characteristics of the valve. So see you later in next video. Thank you so much.